This is the leXsolar SmartGrid Ready-to-go, our experiment system for the efficient networking of renewable energy sources. The components are securely packed in a suitcase and therefore easy to transport. With these, experiments on smart grids at the secondary levels 1 and 2 can be carried out. A very important component of smart grids are storage media. In an experiment, we will now show by which physical principle storage media can prevent unwanted overvoltages due to the installation of photovoltaic systems. For this, we need the base unit and the plugged Smart Control Components power module and AV module, where we only need one power module and the AV module for our test. Furthermore, we need the solar module with base, two light bulb modules, a motor module, potentiometer module, and a reversible fuel cell. We have gathered together almost all the components needed for the experiment. We just need the lamp, several power cables, and a power supply. For the experiment, the reversible fuel cell must be filled with distilled water. We also have all the equipment so arranged as we need to set up. First, we stick the two light bulb modules and the motor module onto the base unit. They are now in a parallel circuit and thus represent a building with many consumers. Next, we connect the power module to the base unit. The power module is a voltage source and represents a power plant which applies a voltage to our building. In Germany, this voltage is ideally 230 volts and a maximum deviation of 10% of this value is allowed at most. For our experiment, we define the nominal voltage to 3 volts with the same percentage deviation. Since we want to have our building at an ideal voltage, we set a voltage of 3 volts on the power module. In addition, we install a photovoltaic system at our building. After we put the solar module on the base, we connect the solar module with the AV module. The AV module allows us to measure the voltage and current of the building. Both devices are now connected together in a parallel circuit of the building. To simulate a high solar radiation, we set up a lamp in front of the solar module. It is placed directly in front of the solar module at a distance of 50 centimeters and with a horizontal beam path. To carry out the experiment, we now turn on the power module and the AV module. Optionally, the AV module must be switched in the current and voltage measurement mode. Thus, at the building, there is an ideal voltage of about 3 volts. We also turn on the lamp. We recognise that the voltage changes and it now amounts to 3.83 volts. This is an exceedance of the maximum allowable value of 3.3 volts. This high voltage can and should be prevented in the future by energy storages. To this end, we install in our solar system the reversible fuel cell with a potentiometer as a pre-resistor. The reversible fuel cell is able to store energy by converting water into hydrogen and oxygen and release it through the reverse process again. The resistor serves for the regulation of the energy supply. At the beginning, the resistance is very high and it does not flow energy to the reversible fuel cell. If you reduce the series resistance now, you can see that the voltage and current and thus the power supply for the building decreases. The reason for this is that a part of the photovoltaic energy flows to the reversible fuel cell. The reversible fuel cell represents various storage media. In everyday use, there will be permanently installed batteries and electric cars for the supply of individual households. Besides the integration of storage media, more physical principles for eliminating overvoltage can be illustrated with the components of leXsolar experiment system. In the accompanying instruction booklet, for example, experiments on the subject intelligent transformers and load management concepts can be found. Further experiments on the structure of the conventional power grid and other problems and their possible solutions through the integration of renewable energy sources and smart grid components are described. For other experiments with the solar module, the azimuth angle scale is ready. It enables a simulated course of the day of the sun. As a further source of energy, the model of a wind turbine module is also usable. It can be equipped with different blade profiles and with different pitch angles. To regulate the wind, a wind machine is available. Meanwhile, wind speed can be controlled by the second power module, which we set aside at the beginning. If the solar panel and wind turbine is located in a circuit, the diode must be used. It prevents the wind turbine from being driven by the solar module. In addition to the AV module, there are two smart meters as more measurements. They can display the current performance and calculate from the measured values of the total energy for a given period. In addition, a model of an electric car is included in the experiment system. The model car can illustrate the typical performance behavior of different types of storages. For this purpose, there is, in addition to the reversible fuel cell, a capacitor. To fix this on the capacitor, the battery adapter must be used as well. For the simulation of line resistances, grid modules are available in the case. They have, like real power lines, the property to heat up due to current flow. On the accompanying CD, there are experimental instructions on background information for the teacher and experimental protocols for the students. We wish you lots of fun experimenting.